In this video I will teach you about resistance measurement, wiring the breadboard, voltage measurement, current measurement and typical faults which you may encounter. Practical skills are so important.
I'll teach it, you are so great. What else will you teach me?
Okay, we're going to go ahead here and measure first of all the 330 ohm resistor. Now 330 ohm, 5%, you'd expect a little bit higher or lower, but not too much. And yeah, we measured on the meter and 346 ohms. Well, that could actually be reading just a little bit high. I mean, how good is this meter? That's what we have to ask ourselves. So then we go to a 470 ohm resistor. And we measure the 470 ohm and we come up with 490 ohms. And again, we should be asking ourselves, is that sort of in the right ballpark? So I'll grab a 1.5k and, 1.2k, and 1.2k, it's out by 15 ohms. That's not a really big percentage in 1,200 ohms. So I'm starting to suspect that the meter could have some resistance in the leads. So I'm going to short these two leads together. And when we do that, wow, we've got 21 ohms of resistance there. So that's not right, that's not what we'd expect to have. So it's time now to think about having a look at the connections on the meter and make sure that they're clean. Check the integrity of the wire itself and then plug them in, give them a bit of a twist. If you're still not sure what you could even do, you can take out the black lead and you could just work with the red lead and come back. That's more like it. We want to see about 0.6 of an ohm, so we know the red lead's good. Take out the red lead, put in the black lead, give it a bit of a twist there. The black lead's giving 0.1, so something's not quite right before. Maybe it was just dirty connections. So there's the two leads in. And about 1 ohm. That's pretty good. That's what we'd expect to see with a meter. So now that we've got that ironed out, we go again with the 330 ohm resistor. 325 ohms. Yeah, that's looking good. That's what I'd expect to see. The 470 ohm resistor. 470 ohms, spot on. And the 1.2k. 1196 ohms. Okay, so this is what you have to take in mind all the time. Calibrate the equipment before you actually start using it, because if you're using the equipment and it's not calibrated, the results you get are going to be meaningless.
Get yourself a piece of paper and draw the circuit on the paper, and then make space for the components and lay them out as I've shown here in this clip. Makes life very easy. Because the alternative would be just having components laid out on a bench top, and if you're not sure about the colour codes, you're going to get them mixed up. It's a certainty. So don't do that.
Yeah, baby.
This is your circuit drawings. Study it and learn how to read it and how to redraw it more simply. This is really important stuff.
Okay, so this is a jumper in the board, and while we could simply get our components and we could run them like from here across to here, and then I've picked up a jumper here. You know, a lazier way of interconnecting the resistors might be to do this. Not use the jumper to connect the resistors together like that, but do away with the jumper and simply pick up the end of that. And we know from previous study that we've got 1, 2, 3, 4, 5 in a column all interconnected on the back of the board. So we could sort of do that, but the trouble is later when we come to want to measure current in the circuit, I mean, measuring voltage is going to be no problem at all. We can put the meter across. But to measure the current, we need to break the circuit. And breaking the circuit sometimes a lot easier using a jumper, and then we can come out of the board with jumpers, or at least more readily see where we're going to be interconnecting with the milliamp meter in the circuit. So to make these jumpers, it's a simple matter of probably choosing one colour of wire. Now, it's important to note here, some of these wires that I've taken from the construction box, they've been used by students to put circuits together. This is about 12 millimeters long, and that's way too long. If it's longer than about 5 millimeters, it's too long. Because when the wire goes down into the board, the wire could actually go down through the bottom, past the metal connector, the spring-loaded connector, and then jump across and short out into the next column. We don't want that to happen. So what I'm going to do, it's all bent anyway, so what I'm going to do here is go ahead and cut that off. And I'm going to start afresh. Now, strip these to the right length. And there's the right length there. About 5 millimeters. So what I'll do now, about 5 millimeters. So what I'll do now, I'll go ahead and I'll make up about half a dozen small connectors, little jumpers or joiners that are going to join up my resistors in circuit. So I'll just get that done and then we'll come back. Alright, so I've made the jumpers now. You can see I've got a handful of jumpers there. Takes the time, it's worth taking the time to sit down and neatly make these in advance. And you can see the bared ends of the jumper. It's quite small. No need to have any more than about 5 millimeters there. That's more than enough. In fact, this one here is getting a little bit on the long side, and it's got a nasty sharp hook on the end. That probably should be trimmed before it's used in the board. Takes excess pressure to push that in anyway when it's got a nasty hook on the end like that. Little tricks that you get used to when you're making circuits. After all, you want to make this thing and you want it to work the first time, so we don't want to go round and round in circles and try to fault find something that should have worked the first time through. Especially if this is a practical test. You don't want to be wasting too much time because you've inbuilt errors as you go. Now when we look at the circuit, we can see that there's a 270 ohm resistor. It's red, purple, brown here. Red, purple, brown. So 2,7 with 1 0 on the end, and the gold band is 5%. And that's going to be followed by 680 ohm in parallel with a 560 ohm resistor. So this is where the trusty little board comes in handy that I took the time to make up in advance, and I can sort of put that in the camera's view there, and I've just scratched out a very rough circuit, and then I've laid out all of those resistors, and that allows me then to grab the resistor I want without having to go through all those resistors on the bench and sort them all out again. So we want a 680 with a 560. So I'll start off with the 680 ohm resistor. Well, I'll start off with the jumper lead first. So I'll put this little jumper in to neatly come across to the top of another column, like that. And then I'll put the 680 adjacent to that, and I'll come down and I'll put the 560, maybe a couple down below it, because they're in parallel. So just duplicate that there, come across to a new column. Again, I won't use the whole right adjacent to it. I like to come down a little way away from it so that I've got a bit of space on the board, and I know that then I'm not going to be shorting out the individual wires. So then from there the circuit shows that we go into a 330 ohm resistor. So I'll come down to the end of that column there, and I'll make a new jumper that goes across to, well, I might even come right across to here on the board. Why not? Neatly come across to there. We have to pick up the 330 ohm resistor, so I'll grab one of those from my piece of paper, plonk it in there, and then I'll sort of come back the other way in the circuit now. 330, and the circuit says that 330 lines up with a 150 ohm resistor, so I won't put that directly in line with it. I'll use again that little jumper method. I'll just leave a gap there and put the jumper. Jumper coming over to there, and then we'll pick that up there. That's the 150 ohm resistor. You sort of get a bit of a feeling for hooking these up after you've made a few. You can use a pen to square off the circuit if you haven't got a small pair of pliers. Pen makes a good job here. You can just get the leads to the right sort of radius bend, and you know, I'm making sure as I go that I haven't sort of, can I say, gone dyslexic. I haven't sort of looked across the columns here. And I've made sure that the wires all in fact line up, because what I've found over the years, I mean 20 plus years of teaching shows me that students call me over and say, I can't get any current, you know, and I look at the thing and there's a wire in one column and there's a resistor lead in the column, one up or one down, and that's just not going to work. You've got to take a bit more care with the building of the circuit. Alright, now I've got this 1K resistor which I have to put in place, and the 1K resistor goes from the end of that 150 ohm up to the junction, the big junction that I had up here before. So what I'll do, I'll pick up that junction, come down here with another piece of wire, jumper here, and then pick this one up. Well, look, I won't use a jumper on this one because these are directly in series, and if I was asked to measure the current in this resistor or its buddy that goes in series with it, I can break the jumper at this end or at the other end, because the current is going to be the same in that as it is in this. So I won't bother putting a jumper in here. Now what I have found here is a bit of wire stuck in one of these holes. This you're going to encounter where people that don't know what they're doing, or they're just damn careless, break things off in the board and then don't tell anybody and put the board back out the front. Please don't do that. If you break something off in the board, let me know and we'll take steps to get the board fixed, because there's nothing worse when somebody else goes to use the board then and it's got that bad problem associated with it. So there's the 330 and the 150 ohm resistor. The only thing left now to do, no, I can see I've made a little mistake. Just looking at the circuit now, I've got 330, no, that's right, 330, 150, and this is the 1K, isn't it? That's the 1K. So that'll be okay. I've just got to take important note where that junction is there, and I'll use the longest little jumper wire that I've got left, and I'll pick up from the intersection of that. Just look at my scratchy little circuit here. So there's the 1K shooting up that way, the 150 and the 330 were in series. So now I've taken a jumper from this section here, and I'll come out of the whole circuit with a 330 ohm resistor. So I'll run that jumper across to here, that up and come out of the whole circuit. Alright, so there we have it. That's the 270 coming in, 680, they meet up with the 680 and 560 in parallel, which they go across to the 330 ohm, that jumps across to 150 ohms, that goes through a 1k back up to this junction of 3 individual resistors, and at that point also comes to a 330 ohm resistor which comes out of the board. So the board connections are here, which I'll call positive, and here, which I'll call negative on the circuit. So what that needs now is to connect up to the positive connection on the top of the board and the negative connection on the top of the board, and that'd be great because then I can use the wires that come from my power supply unit, and I can put one there, and I can put one there, and I can apply the voltage then into the board. Alright, so I'll just cut some more wires and I'll hook that up, and then we'll adjust the voltage, and then it's time to start taking some measurements and noting them down on the test paper. What I've done now, I've completed the wiring like I said. I've used a nice blue wire for the negative side and a red wire for the positive side. Red to red, red connected to the positive terminal on my power supply unit, and I've used blue for the negative rail up to the black terminal, black going to the negative on my power supply unit. So very easy to identify exactly what lead is what, and the circuit, like I said, it's laid out very neatly. All of these nice little jumpers allow plenty of breathing space on the board, and makes it very easy for me to fault find that and trace the circuit through and seeing what's happening. Quite often you'll find that the way the circuit's drawn, you should just be able to basically map out the board according to the same legend on the schematic diagram. Now, something important to note, the power supply here says 14.8, the voltmeter here, the fluke voltmeter, says 14.99. There's a coarse voltage control here and there's a fine voltage control here. I'm going to connect this, I'm going to adjust this fine voltage control to get just a shade over 15 volts here, so about 15.0403, something like that. I'll be fine. Don't rely on this one here because it's not going to be anywhere near as accurate as what your meter is. So effectively I've got 15 volts now at the terminals on the board. Now it's time to take the first voltage measurement, and that's the voltage across the 270 ohm resistor. Of course I'm going to be writing these down as I go, so that's quite important to note things down on the practical sheet as you go. Don't want to be going and sort of double handling with all those things. Now, does it matter about the polarity on the leads? The positive lead of the meter always has to go, whether it's current or voltage, has to go to the most positive side of the circuit. But with a voltmeter, it doesn't really matter, because if you get the leads around the wrong way, you're just going to get a negative sign come up in front. But the quantity is going to be the same. So I'll put these the wrong way, and just to demonstrate, I'm getting 3.93 volts, but it's got a negative sign in front. That's because I put the negative lead to the most positive side of the circuit. If I put the voltmeter the correct way, that is with positive towards the positive end of the circuit, negative towards the negative end, I get 3.93 with no negative sign showing there. So I can write down on my piece of paper now, I can write down next to that 270 ohm resistor that 3.93 volts. And of course my map tonight, my piece of paper, is very basic. It's just basically some scratchings on the paper, but nevertheless it's enough for me to work with. The next one is a 680 ohm in parallel with the 560, and of course we know resistors in parallel. We only have to take the measurement across one of those resistors, because every resistor in the branch is going to be the same value. So 2.495 volts across that one, and the one below it, which is the 560, 2.495 of course. 2.495. 2.495 volts. Neatly show on my piece of paper exactly where that is. So I've drawn arrows there saying it goes to there and it goes to there. 330 ohm resistor. Go across him. And again, I've got the leads the wrong way around here with a negative sign on the meter. 2.665. Doesn't matter, I'm only after the value. 2.665. 2.665. Cross here. Okay, and I'm going to work my way around the circuit like that, working out exactly what voltages I've got happening in the circuit. So, up to now, what we've done, we've looked at how to do the voltage measurements across the individual resistors and the branches. But what about when it comes to doing the currents? This is where students usually fall down. It's important to understand that you have to break the circuit, and that's why we went to the trouble to put the jumpers in the first place. If we now understand that we can just remove a jumper and use the meter in the current meter mode, set to milliamps. On my fluke it'll be, I've got choice of two ranges. I've got the 10 amp range and I've got a 300 milliamp range. This circuit only draws a total of about 18 milliamps or something total. I calculated that beforehand mathematically, so the 300 milliamp range will be fine. You do have to be very careful with measuring current. If you make a mistake, you're going to damage the meter, or at a minimum blow the fuse in the meter, meaning that the meter has to be repaired. So be very careful when you're doing the current measurements. Now I'll go ahead and I'll change the leads across on my meter to the milliamp range. This is my own personal fluke meter, so like any meter you've got to take care with it, and if you look after the meter it'll last for a long time. I've got to put the range selected down to not AC current but DC current. I've done that now, DC current, again with the polarity. Doesn't matter if I get the leads around the wrong way, it just means that I'm going to get a negative sign come up in front of the display. But I know which direction the current's flowing in the circuit. Simple circuit like this, I'm not particularly worried about the direction, the polarity, but I will endeavour to always use the positive lead on the most positive side of the current supply in the circuit. Alright, so I'll do the main current first of all. I'll break the first jumper, and because that's from the first resistor through to the next branch, that's going to be the total current flowing in my circuit. And bingo, we've got a meter with a blown fuse. Well done. Okay. Alright, so it's going to be back down to the garage and go and find another meter. These things happen. I just thought to show this small toolkit. Very handy, very inexpensive. A couple of screwdrivers, really handy pair of pointy nose pliers, especially for doing breadboard work, and a small digital multimeter. So even though it's not a really high quality one, it's better than nothing and it'll get you out of trouble. So that's what I'm going to use now, because the fluke has a blown fuse on the amps range. So for current, I'll be measuring with this meter now. Taking out the first jumper to measure the current, because after all the current that flows through that 270 ohm resistor flows through the entire circuit. So taking out that first jumper, we could use fingers to do that, but a little bit messy because you might make a mistake on the board and disturb something else. Sometimes you're better off to use a pair of needle nose pliers. And they come for a very inexpensive price in a kit like the kit that I showed earlier. So I could just lift one end of the jumper, but I'll take the whole jumper out of the board. And with that jumper removed, then it's a case of using the current meter and putting the meter across where that jumper was. So the current meter takes the place of the wire jumper, so that all the current that travels through that 270 ohm resistor now must travel through the milliamp meter. So let's do that. Positive side of the meter to the most positive side of the circuit, 14.38 milliamps. Pretty well exactly in accordance with what the calculations say it should be. So that's the total circuit current, IT, 14.38, 14.39 milliamps. Just flickering there a bit on that little Digitech meter. Small, cheap meter. It's not going to be quite as accurate as a more expensive one, but it's not bad. Factories these days are very good. So I'll put that first jumper back in the board again, and then we'll go ahead and we'll see how we have to do the current in the 680 ohm resistor. So that jumper's back in. Now I've got a 680 ohm resistor above a 560 ohm resistor, and I want to find the current that just flows through the 680 ohm resistor. So how do I do that? Well, I just have to lift one end of that resistor from the board and just sit it up in the air a little bit. And then using the current meter again, the positive lead of the current meter to the resistor and the negative side of the current meter to where the resistor would have gone. So that is joining up with the 680 ohm resistor, the 560 ohm resistor below it. So doing that, and 3.64 milliamps. 3.64 milliamps. So we could do the same thing. I'll put that resistor back in. We can do the same thing now for the 560 ohm resistor. We'll take one end of the 560 ohm resistor out of the circuit. We'll put the positive lead from the milliamp meter onto that. We'll put the negative lead from the milliamp meter onto where it would have gone in the circuit. 4.41 milliamps. Of course, slightly smaller value resistor than the 680 ohm. So we'd expect a little bit more current to be flowing through that. Alright, I'm going to put that back into the circuit. Now, I want to measure the current that flows through the 330 ohm resistor as well. So to do that, I'm going to take out the wire jumper that I put in going to that 330 ohm resistor. I've taken out the wire, and again, now I can put the positive lead of the meter onto that wire, the negative side of the meter, just put the meter in where I can see it on the camera, the negative side of the meter onto the 330 ohm resistor lead to measure 8.06 milliamps. So using the jumper that we put in the board before, this makes the measurement very, very easy. Go ahead and I'll put that lead back into the circuit. Now, if you've taken the time, like I showed you, to set up the board, use good layout on the board, put the jumpers in the right place, put the resistors, identify the resistors and put them in the right place. It makes it very simple then, knowing how to use the meter to measure voltage, knowing how to use the meter to measure current. Don't make a mistake with the current. If you put the meter on the current range across a voltage, you'll damage the meter. Don't do that. Measuring the current, we have to break the circuit and the current flows through the meter. Measuring a voltage, we measure across a component. That's very important. Marks will be lost for incorrect use of equipment. Marks will be lost for not being able to build a circuit. Marks will be lost for not being able to identify individual components, and of course marks will be lost for making a mess on the board, not laying it out neatly, because after all I have to come around and look at this work and be able to identify what you've done. So if you can do all of the things that I've showed here correctly, you're going to get approaching 100% in this practical test, and that's what you're trying to get.